Hey there, future scientists. Have you ever wondered what makes up the world around us? It's all about chemicals. And guess what? We use special codes called chemical formulas to represent these chemicals. Cool, right? Chemical formulas are like secret recipes for molecules. They tell us which elements are in a molecule and how many of each element. Just like a recipe needs the right ingredients in the right amounts, a molecule needs the right elements in the right proportions. Imagine baking cookies. You wouldn't mix a whole bag of salt into your cookie dough. Chemical formulas help us understand and predict how different chemicals will behave. So are you ready to unlock the secrets of chemical formulas? Let's dive in. Before we can write chemical formulas, we need to learn the language of chemistry element symbols. Each element on the periodic table has a unique symbol, kind of like a nickname. For example, H stands for hydrogen, O for oxygen, and C for carbon. These symbols are important because they let us write chemical formulas in a shorter and more efficient way. Imagine writing sodium chloride every time you wanted to talk about table salt. Instead, we can just write NaCl, which is much easier, don't you think? Now that we know some element symbols, let's see how we can put them together to make chemical formulas. It's like building with Legos, but instead of bricks, we are using atoms. The simplest chemical formulas are for compounds made up of only two different elements, like water. Water is made up of hydrogen, H, and oxygen, O. The chemical formula for water is H2O. The 2 next to the H tells us that there are 2 hydrogen atoms for every 1 oxygen atom. It's like a recipe. 2 parts hydrogen and 1 part oxygen make water. Sometimes figuring out the right chemical formula can be a bit trickier. That's where valency comes in. Valency tells us how many other atoms an element wants to bond with to be stable. Think of it like a dance floor where atoms want to hold hands with other atoms. Some atoms, like hydrogen, only have 1 hand to hold, while others, like oxygen, have 2. So, to form a stable molecule, the atoms need to pair up in a way that all their hands are holding on to another atom. For example, in carbon dioxide, carbon has a valency of 4, meaning it wants to bond with 4 other atoms. Oxygen has a valency of 2, so to make a stable molecule, 1 carbon atom bonds with 2 oxygen atoms, giving us CO2. Sometimes groups of atoms like to stick together and act like a single unit, kind of like a team. These groups are called polyatomic ions, and they have their own special names and charges. One example is the sulfate ion, which has the formula SO42. This means it's a group of 1 sulfur atom and 4 oxygen atoms that carry a -2 charge. Polyatomic ions can make writing chemical formulas a little more challenging, but with practice, you'll be a pro in no time. Just like learning to ride a bike or play a musical instrument, mastering chemical formulas takes practice. The more you practice, the easier it will become to remember element symbols, valencies, and how to put them all together. There are lots of fun ways to practice, like using flashcards, playing chemistry-themed games, or even trying out some simple chemistry experiments at home or in school with a teacher's supervision, of course. Congratulations, young chemists! You've taken your first steps into the amazing world of chemical formulas. But this is just the beginning. There's so much more to explore in the fascinating realm of chemistry. Remember, keep asking questions, stay curious, and never stop exploring the world around you. Who knows what incredible discoveries you'll make? Keep up the fantastic work, and let's continue to unlock the secrets of science together.